got everybody's imagination. So, and Mars is very cold. Option would be to terraform the place, okay? You want to introduce warmth. You want to block the ozone. You want to block the ultraviolet so that you can protect organic life. And we release some of the CO2 that's frozen on the poles. Can we get the water back out? You know, the water molecule. Do we have enough resources on Mars such that if the spaceships from Earth stop coming, people arrive? Yeah. Well, I think it's going to take a while to build a real civilization.
Mars is the fourth planet of the solar system. It is a cold and dusty desert world with a very thin atmosphere. It is also a dynamic planet, with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. It is one of the most explored bodies in our solar system, and it's the only planet where we've sent rovers to roam through the landscape to gather important information about the soil and atmosphere. Unless you have been living underneath a rock, you might have heard about terraforming Mars and make it habitable for humans. But what is terraforming? Terraforming is the hypothetical process of deliberately modifying the atmosphere, temperature, surface, topography, and ecology of a planet to be similar to the environment of Earth, making it habitable by Earth-like life. Even if the environment of a planet could be altered to a certain extent, the feasibility of creating an unconstrained planetary environment that mimics Earth on another planet has yet to be verified. It would be a monumental task. While Mercury, Venus, Earth, Mars, and even the Moon have been studied in relation to the subject, Mars is usually considered to be the most likely candidate for terraforming. Terraforming Mars would require the atmosphere to be thickened and enriched with nitrogen and oxygen, while the average temperature of the planet must be increased substantially. But how? There had been 3 proposals so far, each with its own set of limitations. The first one would be the use of greenhouses, gas-producing factories that will trap solar radiation and warm up the planet. Another method would be smashing ammonia-heavy asteroids into the planet to raise the greenhouse gas level. The last one is the least feasible with our current technology, and it involves large orbital mirrors that will reflect sunlight and heat up the surface of Mars. Water. It is an essential component for all known forms of life. Without it, life would not be possible. Mars was once filled with water, with a denser atmosphere and higher surface temperatures. Water on Mars can currently be found at the North Pole as a layer of ice, several kilometers thick. Extracting it would prove to be a challenging task because of the freezing temperatures. To overcome this problem, we could use rovers. They will select the location for the settlement primarily based on the soil's water content and extract water from the soil. Before being consumable, the extracted water would need to be purified from toxic chemicals and bacteria found inside. Gravity plays a crucial role in the machinery of life. On Earth, our species has evolved many times to adapt to its local gravity. But on Mars, gravity is just 38% of that on Earth. To make a comparison, an adult who weighs 100 pounds on Earth would weigh 38 pounds on Mars. This has a detrimental effect on the bones, muscles, and blood system. You lose mass as time passes. In the International Space Station, the crew has to train with aerobic exercises to slow down the process of bones and muscle decay. The same training would be required on Mars. A low-gravity planet would also raise reproductive concerns. We don't know how it will affect the mother and fetus during their phases of development. The amount of light that hits Mars is only 40% of what it is on Earth, and it might be considerably lower, due to dust clouds covering the planet's surface. This can lead to health issues such as vitamin D deficiency and cardiovascular diseases. But that's not all, because the light is so poor, we would have a hard time producing energy through solar panels. Also, geothermal energy and wind power would not be effective as well, due to the underground low temperatures and thin atmosphere. The only way we could attain energy on Mars is through nuclear reactors from the Earth, which may provide energy for decades. The soil is cold and radioactive, primarily composed of alkaline soil with a pH of 8, which contains excessive amounts of sodium, calcium, and magnesium, and is often called sweet soil. The soil becomes less soluble and has difficulty absorbing nutrients or allowing the roots of nearby plants to receive nutrients, making it nearly impossible to grow anything in it. To grow crops, we would need to build hydroponic greenhouses which require special lighting, as well as genetically engineered plants designed particularly for thriving on Mars. Because of the enormous distance between Earth and Mars, the only time window in which Mars could be supplied with new resources would be every 2 years, when the distance between Earth and Mars is at its shortest. If there is an emergency on the outpost, we from Earth would have to wait until the next travel window opens, by which time it would have already become a barren wasteland.